Newton's law of gravitation says that the force of gravitation between two bodies is G m1 m2 over the distance between them r squared. So if we consider F1, which is the force due to the ball or the charge of the planet or the star, whatever it is, doesn't matter what it is, but think of it as the option on top on the point O or the mass O due to that object is going to be G, which is 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared, times the mass at O times the mass at the other object. So we have at O it's 1 times 10 to the 30th kilogram, and at the filled in top star it's 8 times 10 to the 30th kilogram. And the distance between this point and this point is given by the Pythagorean theorem, and since we have 2 times 10 to the 12th going horizontally and 2 times 10 to the 12th going vertically, it would be the square root of this squared plus the vertical distance squared, and then square it, so it's just going to be 2.00 times 10 to the 12th meters squared plus 2.00 times 10 to the 12th meters quantity squared. If we do this, we get about 6.67 times 10 to the 25th newtons. Similarly, if we use the equation for F2, we will have similar numbers on the top. It's still G, which is 6.67 times 10 to the minus 12 Newton meter squared per kilogram squared. The mass at O is 1.00 times 10 to the 30th kilograms. The mass of the other one is 8.00 times 10 to the 30th kilogram. And now the distance between this point and this point is only 2.00 times 10 to the 12th meters quantity squared. And this gives us about 1.33 times 10 to the 26. Now we found the two forces, and remember forces are vectors. That's why we identified them as pointing with arrows in the graph. So let's get the components now. So we can say that F1 in the x direction, we're told that we have an angle of 45. So this is going to be 6.67 times 10 to the 25th Newton times cosine of 45 degrees, which is going to equal 4.72 times 10 to the 25th newtons. F1y, is going to be the 6.67 times 10 to the 25th newtons, but now times sine 45 degrees, which means this is also going to be 4.72 times 10 to the 25th newtons. And now notice for F2, it only has a horizontal component. So we can say F2x is our 1.33 times 10 to the 26th Newton and f2y is going to be 0 because it doesn't have any components vertically. And now if we continue, we can say that f sub x, the resultant force sub x, is f1x plus f2x. And if we take this number and add it to that number, we get 4.72 10 to the 25th Newton plus 1.33 times 10 to the 26th Newton. That gives us 1.81 times 10 to the 26th Newtons. And f sub y is going to be f1y plus f2y, which is going to be 4.72 times 10 to the 25th newtons plus 0 newtons, which is 4.72 times 10 to the 25th newtons. And that will mean that F, the resultant force, or the force on O, is going to be the square root of the x component, 1.81 10 to the 26th newtons quantity squared, plus the y component, 4.72 times 10 to the 25th newtons quantity squared, or 1.87 times 10 to the 26 newtons. And the angle theta that the resultant force F makes is going to be tangent inverse of Fy, which is 4.72 10 to the negative 20, 10 to the 25th newtons over 1.81 times 10 to the 26 newtons, or about 14.6 degrees. So if we go over, then we can say that F is going to be this red vector, which we get from the sum of these two, and theta would be just this angle from the horizontal to that F.